This is a follow-up video to a video I posted a few days ago in which I explained that I would use something like TIG welding to repair an item like this. The video wasn't really about repairing this particular component. It was really about using TIG welding as a method for repairing cast aluminium parts. And I did get a comment that I thought was quite interesting, so I wanted to address it, because although I'd said that TIG welding was a very good technique, and in my opinion really the only technique for doing this, the comment kind of introduced something that I wasn't really discussing, but does or did make me realise I hadn't really explained why I would recommend TIG welding as being the best approach for this. I did say there are other methods. I didn't say what the other methods could be, but in my opinion what I said was TIG welding is by far the best option for a repair like this. And in this video I just want to really clarify that, and also partly respond to the comment, because it was an interesting comment. And one of the issues is if you've got something like this to repair and you don't have a TIG welder, or you don't know how to TIG weld, then TIG welding is obviously not going to be an option for you, so you need to find other ways. However, if you want something that is going to be as strong as the original, then TIG welding is probably the only way you're going to achieve that. This particular part is a good example of why I would only consider TIG welding something like this. It is right at the front of the machine. When the machine's in use, this is raised and you're resting your hands on it. The machine's picked up using this very heavy machine, so a lot of stress goes through this point, which is obviously why it's broken in the first place. Also, it's a bit of a weird shape where it joins quite thin material. Cast aluminium, very old cast aluminium, basically pot metal. It is literally mostly air. There's very little actual metal in this. And so in the previous video I said that I would use TIG welding, but someone in the comments said that the method they would use is very different. But if we just go over the other method, I thought it might help clarify why I was recommending going to all the time and trouble of learning to TIG weld if you don't already know how to. And I would say at this point, if you do decide you'd like to learn to TIG weld, that it's not an easy, cheap or quick thing to learn. You're looking at probably several £1000s even to get into it in a fairly basic way. You're going to need a welder for a start. It has to be an AC welder to do aluminium, and with the features you're going to need, the welder alone, even a cheap one, is going to cost you probably over £1000. You're then going to need other equipment, a welding helmet. You're going to need argon gas. When you're using TIG welding like this, then you use pure argon. That's about £100 a tank for a relatively small tank. And then you've got consumables. You've got filler rods, tungstens, that sort of thing. Not horrendously expensive, but early on you're going to burn through a lot of tungstens and filler rod and basically these pieces of scrap metal that you're going to practice on. So it does get expensive. Once you get into it, a tungsten is going to last much longer. They're only maybe £4 or £5 each, but you might get through 20 of those a week when you first start learning. But I think the tungsten I've got in my 17 size torch has been in there now for probably 100 hours of welding, so they do last a long time once you kind of get the hang of it and you stop destroying them. But really is the point of this video is why I would recommend learning to TIG weld to repair something like this. So I'm going to start by just going over what the comment suggested as being an alternative, and it is a viable alternative if you've got no other way to do this. It's not something I would do. It's I think almost certainly going to result in a failure, but it's probably worth having a go at it if you've got no other option. Now I'm going to simplify the idea here, but what the commenter I think was suggesting was if you have the two pieces, I'm going to simplify the brake here, which again it's not a simple brake, it's a compound brake. It goes in various directions and it's not on a flat piece of material. It's kind of a T-shaped with a curve, and that makes it even more complex to try and repair. But what he was suggesting was drilling a series of small holes. Hopefully you can see what I'm drawing here on both parts, and then machining out. Obviously it has to look right, so you have to end up with something that where this side is going to look the same as this side. This is a visible part of the machine, and even if it wasn't visible, as I've said on previous repairs, even if it's not a part someone sees, I'm restoring irreplaceable equipment here, so I need the repairs to look right as well as being successful and strong. So what he suggested was drilling a series of very small holes, and then basically machining out channels, and then putting some carbon fibre and kind of weaving carbon fibre back and forth across the joints, kind of like stitching it, and then impregnating the carbon fibre with some kind of strong adhesive. Now that will kind of hold it together, but I can guarantee that this is going to fail after a fairly short amount of time. Now remember that this material is only about 2 millimeters thick, so even if you only, we'll look side on now, even if you only recess each side by 1 millimeter, then that means you're going to take away half the material from one side. And even if you alternate it side to side, this, as I said, is pot metal. Don't confuse this with machined billet parts that you might get on a more modern piece of equipment. This is basically air held together with very thin bits of poor aluminium and lots of other impurities. So it's a very poor material, it's very weak to start with. It's really the shape that gives it its strength. It's also very brittle. So the problem you're going to get here is you've created a series of weak spots, and it doesn't matter how strong this carbon fibre is. You can, if you imagine you just put a solid piece of 2-inch thick steel here and bolted it through, it doesn't make any difference. The ultimate strength of this join is where the holes are, and you've created stress concentration points. And so what will happen here, I can pretty much guarantee, is it's going to break across the holes. And so the first time any real stress is put on this, it's just going to break off. And even if it doesn't break off the first time, then you're going to get cracks developing. And so this pot metal is extremely susceptible to cracking. And you just get cracks forming here, and within a very short time this whole thing will fail. And then this entire chunk will drop out. And you end up with a much bigger problem to try and solve than you started with. So although that method, it might work in some instances, and it's probably a viable method, it's not one I would ever use, and certainly not for something like this. Give it a go if it's the only option you have, but I wouldn't hold out much hope for long-term success on this. There are other steps in repairing this that I'll go into when I post the videos on the repair and restoration of this. There are other steps that are required that again totally preclude or exclude this as a method. And as I say, the reason I'm saying it's a straw man argument is because I wasn't really talking about repairing this particular piece of the machine. There are other steps that I will come to, and you'll see why this is not a viable method for several reasons. But if we now look into why I recommend welding as being the alternative or the best solution, if we take the same starting point, we have the two pieces of material that we want to join together. And what we really want is to end up with a single piece of material. We don't want to have just a finite number of stress points. As I say, it doesn't matter how strong the carbon fibre is here, that's not where it's likely to fail. It's almost certainly going to fail where the holes have been drilled. And even if you stagger them, you're going to need quite a few of them to give you the strength across the join, so they'll be fairly close together. It's quite a thin cross-section material, it's pot metal, it's going to fail. There's no ifs or buts about that. It's almost certainly going to fail fairly quickly. Whereas welding is kind of the same thing, but on a kind of much smaller scale. So if we look at the way I recommended welding this and the way I said I would do this, we have the two parts we want to join together. It's not quite as simple a shape as this, but the principle is the same. If we look side on, then what I would do is I would start by grinding out. So I'd clamp it all in place and I would grind out some material along the join. And what we then do is completely fill that join with weld material. It would end up proud, but would end up with some what amounts to a solid fill. So the thing I pointed out, and I'll show you this again, is the important thing here is what I pointed out is this penetration into the base material. So what we're not doing is we're not simply sticking a weld on top of the gap, and this is one of the things, if you're not familiar with welding, this is not what you're aiming for. You're not aiming to put a join on top and a join on the bottom. What you're aiming to do is completely replace the metal where the break was with new material. And so what we do is we grind away part way through. You can go all the way through if you want and do that way. I prefer to do it on both sides if you have access to both sides, of course. You then replace the what is then a void, and you fill it with filler material, and that will go all the way along the join. So this entire space is now new material on one side. Hopefully these areas you've kind of got the new filler to penetrate into the base metal, which we'll have a look at in a few minutes. You then flip this over and you do the same thing from the bottom. So you grind away these corners and then you fill in the void you've now created. And what you end up with is a completely filled void. I'm just going to zoom you in so you can see that a bit more clearly. So what we've done is we've completely replaced this area of material. So where this gap was is now all completely new material all the way across. So we've effectively done almost an infinite number of these cross links. The difference is we haven't created single point stress concentrations. What we've tried to do is merge the weld and get it to penetrate quite deep, so it's not just ending where the filler ends, it's kind of merging quite a long way into the base material, and so it's kind of branching out within the base material. We've replaced all the material around the break, so this now, once we've ground it back, is effectively a single piece of material again. It's not two pieces with some scabs that we've popped on top that could drop off or just pull bits of the base metal out. It's an entire repair where we have impregnated the base material with new metal. And just to try and clarify exactly what I'm talking about here, if you remember, I did two test welds. So this is how the other one looks. I don't know quite how clear this comes across, but I've cut this in half. I've cut across the weld that I made, and then I've ground it using a belt sander to hopefully show you a cross section. And this was a thin wall, so you can see basically how thick it was at this point. And I don't know if you can see this or not, but the filler material, which is on top here, is a slightly different colour, but it extends well down into the base metal. So it's going. So I don't know if you can see it, but the filler material is going well down beyond where the filler seems to end. So the filler seems to end about here, but I don't know if you can see it is extending down, kind of down here. So nearly twice as deep as it appears to from the outside. There are no voids, so we don't have any gaps, and this is pot metal as well, so it was very dirty. I didn't even bother cleaning it. And on both sides we've got full penetration deep down into the material, and so this is now effectively one piece of material. You will not be able to break this top piece off. It's now an integral part of the base metal. So it is as strong as it would have been if this was originally part of this component. And that's what we're aiming for. We're aiming to effectively replace the gap in the metal with solid material all the way through and all the way along the join. We're not creating lots of little stress points here that will all join together and cause a failure. And that's why I recommend using a technique like TIG welding, because it gives you first the ability to weld it. It's one of the few welding methods that certainly I'd be able to use to effective repair like this on this type of material. Again, don't confuse this with billet machined parts. It is very different. It's extremely tricky to weld this. It's dirty, it's impregnated with oil and dirt and all sorts of stuff that's it's picked up over the years. Again, another reason why glue doesn't really work, but there's also other reasons why this method is not suitable for this. Now, I will come back to that in the videos when I repair this actual component, because there are other steps involved that would cause this to fail. But hopefully that's gone some way to explain why I prefer to use a technique like TIG welding to make repairs like this. It gives you an absolute repair. It's not going to fail unless the same stress is put on that caused the original part to fail, of course. But in theory, I would expect, if this repair is carried out properly and we apply a stress in the centre of this, I would expect the other end to fail rather than the repair, assuming that I've done the repair correctly and got the right amount of penetration, because this new material is a lot stronger than the base material that we started with. Okay, well, hopefully that explains why I would recommend considering learning to TIG weld. Not something that should be undertaken lightly, but it is a lot of fun learning to TIG weld anyway, so it's something that in its own right is a fun thing to learn, but certainly for a repair like this is an invaluable tool in your arsenal.